Hello everyone and welcome to PadhaiX. In this video, we'll solve NCERT Class 11 Physics question number 3.14 from the chapter Motion in a Plane. Let's first understand the given situation. A stone is tied to one end of a string of length 80 centimeters and is whirled in a horizontal circle with a constant speed. We are also told that the stone completes 14 revolutions in 25 seconds. We have to calculate the magnitude as well as the direction of the acceleration of the stone. Since the stone is moving in a circular path with constant speed, this question is based on the concept of centripetal acceleration. So let's solve it step by step.
We have a stone, and it is tied to the end of a string. The length of the string is 80 centimeters. Now, we whirl this stone in a horizontal circle with a constant speed. But wait, the question specifically says constant speed. So before we start solving, let's understand what constant speed actually means in circular motion. Constant speed means that the stone covers equal distances in equal intervals of time. Now, look at the motion of the stone. The stone is traveling along the circumference of this circle. So if the stone moves from this point to this point, the length of this curved path represents the distance traveled by the stone. But what about displacement? The shortest straight line distance between the initial and final positions represents the displacement of the stone.
And there is one more quantity we can observe. Look at the angle swept by the stone during this motion. This angle is called the angular displacement, and we represent it by theta. So now we understand distance, displacement, and angular displacement in this circular motion. Now let's come back to our actual question. We have to find two things: the magnitude of acceleration and the direction of acceleration of the stone. Now, since the stone is moving with constant speed in a circular path, it experiences a centripetal force, which always acts towards the center of the circle. And we know from Newton's second law that acceleration acts in the direction of the net force. So the acceleration of the stone is also directed towards the center of the circle. This inward acceleration is called centripetal acceleration. So we have already found its direction. Now let's calculate its magnitude. Centripetal acceleration is given by a sub c equals omega squared into r. Here, omega represents the angular velocity, and r represents the radius of the circular path. In our case, the radius is simply the length of the string. So now we need to calculate omega. Angular velocity is equal to angular displacement divided by the time taken.
Let's first consider one complete revolution. For one complete revolution, the angular displacement is 360 degrees, or 2 pi radians. And the time taken is t. If we divide them then, we get omega, angular velocity. Now, look at the information given in the question. The stone completes 14 revolutions in 25 seconds. So for 14 revolutions, the total angular displacement, omega, becomes 14 multiplied by 2 pi divided by 25, which is 28 pi radians divided by 25 pi.
Therefore, omega becomes 28 pi divided by 25 radians per second. Great! Now we have our angular velocity. Let's put this into the formula for centripetal acceleration. Therefore, AC equals 28 pi by 25 whole squared multiplied by 80 centimeters. Now we can replace pi with 22 divided by 7, and we have to be careful with the radius. The string length is given as 80 centimeters. We need to convert the radius into meters. So 80 centimeters equals 80 divided by 100 meter. Let's simplify this equation. We can divide 28 by 7 to get 4. Therefore, AC equals 88 pi by 25 whole squared multiplied by 0.8. And on solving this, we get approximately 9.9 meters per second squared. So, we have found the magnitude of acceleration. It is approximately 9.9 meters per second squared. But the question is not finished yet. We also have to find the direction of acceleration. So, let's look at the stone again. When the stone is at this position, the acceleration points in this direction, towards the center of the circle. Now, let the stone move to another position. What happens to the direction of acceleration? It changes, and this is new acceleration. But notice something very important. At this new position as well, the acceleration is again pointing towards the center. So, although the direction of the acceleration vector keeps changing as the stone moves, it is always directed towards the center of the circle.
Therefore, our final answer is the magnitude of acceleration is approximately 9.9 meters per second squared, and its direction is towards the center of the circular path. And with that, question 3.14 is solved. But wait, here's a small bonus. Let's understand what actually happens to velocity and acceleration during uniform circular motion. We have our stone moving along this circular path. Let's take this particular position. Now, what do you think is the direction of the stone's velocity here?
In circular motion, the direction of instantaneous velocity is always tangential to the circle. So this is the direction of velocity. Remember, tangent is a line which touches the circle at just one point. Now imagine that there were no inward force acting on the stone. What would happen?
The stone would try to continue moving along this straight line in the direction of its velocity. But that's not what actually happens. The stone continues moving along the circular path. So what forces the stone to leave this straight line path and continue moving in a circle? It is the force acting towards the center, which produces the centripetal acceleration. So every time the stone tries to continue in the direction of its velocity, the inward acceleration changes the direction of its velocity, keeping the stone on the circular path. And this continues again and again throughout the circular motion. So remember this important idea. The velocity is tangential to the circular path, while the centripetal acceleration is directed towards the center. And that's why, even though the speed of the stone is constant, its velocity is continuously changing, and therefore, the stone has acceleration.
And with this, we have successfully solved NCERT Class 11 Physics question 3.14. If you found this explanation helpful, don't forget to like the video, share it with your friends, and subscribe to PadhaiX for more NCERT physics solutions. Thank you for watching, and I'll see you in the next video, where we'll solve question 3.15.